Felix, can you hear me? I think I accidentally pressed mute. Can you hear me now, Felix? I think I accidentally muted myself. Okay, let me do this part again. So just now I was saying our esters, we generally see that as a volatile liquid, and it is normally used to do certain flavoring, like perfume, and then also as flavoring for food. So they are actually something like in this case, it says artificial food flavoring, right, to create flavors that's not normally found in the material they use. So they can actually, uh, it's actually what do you call that? Like you can create like fruity flavors and things like that, the kind of flavor profiles. Okay, so for this case, for propanol, okay, let's draw this structure. So it's a three. Okay, all the rest are all hydrogen. So I don't draw them so as not to crop the whole structure here. Then your two carbon. Okay, so nothing much here. And then for two carbon acid, we always draw the COH first, then we extend out one more carbon. Methanoic acid, one carbon acid, we extend out the H. And propanoic acid, we have three carbon, so we draw the COH first, and then we extend out two more carbon on the side. All right, so nothing much here. So before we do the naming, right, let's try to get the ester here. So let's talk about ethanol. So to get the structure of the alcohol, butanoic acid, we have four carbon acid. Okay, so when they drop the, because they are forming water, so they have to drop the water molecule. So what they drop is the acid will drop the OH from this. The alcohol will drop the hydrogen. So from here, what is the final product you get? So from the acid side, I'll put in blue. And the alcohol side will put in red. So you can see whichever part that was lost, so they will just attach it like this. Any questions? It's just dropping a H. Okay, dropping a H from the alcohol side, dropping a OH on the acid side, and then when they drop, we just combine them, and then we get water produced. Okay, and then we can see from here, this part here is our ester linkage. Okay, so if this structure is okay, let's talk about the naming. So normally the name will put the alcohol first. So go for ethanol, and behind we have ethanoic acid. And then we have butanoic acid. Okay, to name the ester, what is the name of this guy over here? From here, we minus ANOL, remove this, remove the name for the alcohol. Also minus enoic acid plus YL plus enoate. So the final name we have ethyl butanoate. Right, any questions for this? Okay, how do we write the chemical formula? So one way we write that we will write the formula, right, is we try to show the structure, how the atoms are arranged. So I give you a few ways this thing can be written. Number one, just follow exactly. CH3, CH2, CH2, COO, CH2, CH3. It can be written this way. So from here, right, the advantage of writing it this way is you know exactly how the atoms are arranged in the structure. And the one that accompanies the CO, right? Okay, this one, you can see this whole stretch here, the one that accompanies the CO, okay, where the ester linkage is, this comes from the acid side. And the one with the O, this component, this comes from the alcohol side in terms of the structural drawing. So by looking at the way the formula is written, it helps you to know how many carbon acid, how many carbon alcohol this was made with. Sometimes we also condense all those in front, meaning we can condense this to C3H7, COO, C2H5. Well, this has a very similar way. Same thing over here. Up to this point where the CO is, this part comes from the acid. This portion where the O is your alcohol. Okay, any questions regards to the naming? All right, if no question, let's do question 9 together. So you can see here the name of the ester. So for name of the ester, we'll take put the alcohol in front first, put the acid behind. Okay, and then do the above rule. Then you will see that the name of the alcohol present will be methyl sorry, propyl. Propyl methanoate. Okay, meaning 3 carbon alcohol, 1 carbon acid. Okay, with this, let's look at,
Sorry, Mr. Jason.
yes,
For the chemical formula, right? It doesn't matter which one comes first, like alcohol or acid.
it doesn't matter. It's just following the, because, okay, you can actually draw the alcohol first, then you draw the acid. But normally, I feel that it's a bit easier to see the acid part first, because otherwise we have drawn the ester linkage as OOC. Yeah. But it will be easier to draw the acid first, and easier to see in terms of the whole formula. But when drawing the formula, drawing the structural or the chemical formula, right? It doesn't matter which one you draw first, it's okay. But for the naming, it's always the alcohol followed by the acid.
Okay, thank you so much.
Right. So structural formula of the ester here. So the alcohol. So for part B, this is the methanoic acid. So I'll draw the methanoic acid first. And then we have the propanol. Okay, let's do structural here, easier. Then for the propanol, we have 3 carbon with the OH. So what happens is, the OH will be dropped from here, the hydrogen will be dropped from the alcohol. So what's left behind? Your acid combined with the alcohol. That's all for the structure. For the ester plus the water behind. So for chemical equation, I'll just follow exactly the structural. So we have a methanoic acid. We have the propanol C3H7OH. And then for the ester, this part comes from the acid side, HCO. And then the alcohol side, we have the O, C3H7, and plus H2O behind. Okay, please digest structural and the chemical equation. See if there's any issue with this. The idea is to identify the C double bond O, and then that is the acid component. Okay, so with this, the word equation. Oh, by the way, then this one will be the answer for B. Right, word equation. Okay, that's all. Okay, if you understood this, can I give you a few minutes to explore question 10, work backwards? You are now given the answer. You reverse everything here. Okay, I'll leave the screen here for you all to look at. Time now is 7:57. 8 o'clock, we will go through this part there. Okay, give yourself a few minutes to look at this. Enjoy yourself. Okay, let's take a look at what if we want to draw the alcohol first. So as same way, if you want to draw the alcohol first, I will draw the free alcohol, carbon, and then there's an O here. Now, this thing should not be connected to the hydrogen of the acid, but rather it should be connected to where it's dropped off. So this one should be connected to the double bond O. You see, this is the part where the bond is broken. So this is the part where it will join. These two guys will always join together, always. Then you get this. These two are identical. It's just that the one that I drew for B, it is acid first, whereas this case I draw the alcohol first, but it doesn't matter. It doesn't change the way we connect them together. Okay, these two, this C and this O should always be connected together to each other to form the ester linkage. Then don't forget ester linkage must have this structure COO, where this side comes from the acid side, this O comes from the alcohol. That's why the structure will look like this. Understand? Is that got it?
Yeah, I think so.
Always make sure the C and the O is together. That's like in question 10. Okay, let's dismantle this. Number for question 10. Again, you see the CO, the one with the C double bond O. This is the acid part, where the O is the alcohol part. Okay, so before we do the name, count the number of alcohol and the number of carbon in the acid. So you can see that in this case, Kaylee, we are doing esters. So look for your esters note. So from here, I have a 3-carbon alcohol. So as we see the naming of the alcohol, propanol, drop everything, then become YL. So this is prop YL. This is again propyl. And then for the acid, we have 1, 2, 3, 4, 5 carbon. 5 carbon is pentanoic acid. So it will turn into pentanoic by dropping your respective components in your name. Okay. So we have pentanoic as the name of the ester. So to make this, we need a 5-carbon acid. So pentanoic acid and a 3-carbon alcohol. Propanol. So these are your two substances. So since we already got the names of the substance and the name of the ester, so we have propylpentanoate plus water. So let's talk about the reagents to the structure of the reagent. So let's draw it here. This is your 5-carbon acid. Here we'll draw the C double bond O. And the rest will all be your hydrogen. Your alcohol, 3-carbon alcohol with your OH, and all the rest are hydrogen. The same thing when we have the ester, acid will drop the OH, alcohol will drop the hydrogen. So the acid group, if we have 4 on the side with the C double bond O, okay, and then this will be connected to the alcohol side with the O over here. Remember, this and this will join together. So we have O with 3 C's. Okay, and then we have H2O. So for part C, the structural formula of the reagent is basically this one and this one. Okay, so just now, Zen was drawing the alcohol instead of the acid first, right? If he were to be the alcohol first, it's the same thing. I'll have my 3-carbon alcohol. Okay, and then we have the O here by the acid double bond O with 4 carbon on the side. Then you see the similarity.
Yeah.
Hmm. Okay. Okay, chemical equation. If you have not written down it, can I give you 30 seconds to try it out? Zi, you roughly digest first. I cannot understand that line. The next part we are doing is polymer. So Zi, you'll be ready for polymer. Kaylee also. All right. So for the chemical formula for this same thing, I'll do the condensed version. So for the acid, we have C4H9 COOH. For the propanol, C3H7 OH. Okay, for the ester, we have C4H9. Then we have the COO, the ester linkage here. So I put a COO. Behind, we have C3H7. And then plus H2O. Okay, you can also see that the way we have written this part here up to the CO, this is the acid component. And this side with the oxygen, this is the alcohol component. Okay, please digest. Oh, Ella is not C5 for acid because although there's 5-carbon acid, but don't forget the COO here also represents an acid. So when we name the acid, right, there's 4 carbon here and 1 carbon here. There's 4 carbon here, there's 1 carbon here. But if you were to do it like C5, then there'll be 1 more extra carbon because of the COO behind. We will want to isolate the COOH on its own. Good thing you brought this up, because when I was a student, this thing happened to me also. I thought the 5 is all on the side. Then I totally forgot to put C there. So when I put C5 on the side, I actually got 6 carbon. That's not correct. So remember, for 5 carbon acid, the carbon, this also matters. That's why for our methanoic acid, you notice there's nothing on the side. Okay, methanoic acid, there's no carbon on the side because there's already 1 carbon here. Same logic. Okay, I'm all happy with this. Okay, if you are okay with this, we will look at polymer in a minute. Please digest everything from esters. Esters just like this, nothing much. Of course, this is very basic. Things can get a little bit more messy, but if you understood this, by looking at the formula, how to determine the number of acid, number of carbon acid, number of carbon alcohol required. Okay, how to write the chemical formula in a nice way so you know exactly how many carbon atoms involved. That's good for today. Next week, we'll be doing the O-level questions for organic. Then we'll see more questions from there. Okay, digest this, we'll turn over in a minute. Today I got a lot of casualties, so when I'm doing makeup for the people who are missing, those who missed the Ester part, the earlier one, I'll ask you to join in with them also. Okay, let's look at polymers. Okay, as the name suggests, they are generally giant molecules, and these giant molecules are formed by 2 kinds of reaction: addition reactions, which is involving CC double bond, and condensation reactions, which involve a small molecule that is being taken up during the reaction. What that exactly means, we'll see in a short while. So let's look at the first kind of polymers, which is addition polymer. They come from unsaturated molecules. Basically, things with us. Let's take a look at this. The most basic one is ethene. Okay. And to do addition polymerization, the most important thing is how you draw the start. Is how you draw the starting molecule. So the basic foundation here, the molecule that we use to make up the giant polymer is called a monomer. Monomer is the term used for the basic building block. So if you can see, right, one of the things that you might have seen in lower sec when you are doing digestion, monomer can be seen like amino acids. And when amino acids, a lot of amino acids join up, there you get all your polypeptide or your protein molecule. Your protein molecule or your polypeptides, they are your polymers, the big ones. The small ones, the small unit is your amino acids. And similarly, starch is your polymer. Your basic unit is your glucose. Your glucose is like your monomer. Okay, something like that with that in mind. So in this case, we are trying to join up a lot of ethene molecules so that they turn into a big molecule called polyethylene. So ethene molecule, we have always joined this way. C2H4. Okay, when we are doing addition reaction, we normally draw it something like this. Okay, so when you are looking at addition polymer, okay, this is not good. Remember that. How should we draw it? The only way, okay, the most important thing you remember today for addition polymer is this. The only way you can draw the monomer of your, the structure of your monomer is like this. CC double bond on top of the 2 carbon, below 2 carbon. And then on the side over here, there should be nothing on the side of your CC double bond. If you have something on the side, you are wrong. Remember that. If you ask me why, we'll see in a second. So to fulfill the correct formula for your ethene, so very logically, I will have 2H on the top following the original structure, and the 2 hydrogen that was on the side, we can put it below. Okay, so this is the structural formula of your ethene drawn for the sake of addition polymerization. This is how we should draw it. This is not how we will draw it. Okay, any question, anyone, regarding how to draw it like that? Okay, very important how to draw the structure of the polymer. It has to be in that format. Yo, Eden, we are doing addition polymer right now. Just starting. Okay, so remember, for your addition polymer, it must be drawn like this. You can put whatever you want on top. Okay, you can put whatever you want on top. But it must be drawn like this, no other way. And what's the reason for doing this? Okay, let me show you. The question may ask you to draw the structure formula of the monomer showing 3 units. Now, why only show 3 units, not 4, not 2? Okay, because first of all, it is impossible to draw the entire polyethylene because there may be 10,000, 100,000, or 200,000 ethene joined together to form that large molecule. So to draw the entire molecule, it is impossible. So we can only draw a subset of it. So normally the question will ask for the formula of the polymer showing 2 units, showing 3 units, showing 4 units. Okay, you just follow the question. The question says 3, then you draw 3, and so on. So in this case, I'm going to draw 3 units. So I'll start with drawing the monomer first. Okay, number 1, draw 3 monomer first. So I monomer number 1, monomer number 2, and number 3. Then the second step is the ending step. Break, because this addition addition polymers. So we break the CC double bond and then join them on the side. If we're going to break the CC double bond, break the CC double bond, and we break the CC double bond. And after we break all these bonds already, you notice you got two more. That's how all of them on the top. Okay, you can visualize this as three people with folded arms, aka CC double bond. Okay, and then they unfold their arms to hold hands with their neighbors. Okay, you fold your arm with a CC double bond, you open up you unfold your arms and you hold hand with your left and right, you form a long chain. That's the simplest way I can envision for you how this thing looks like. But basically, it's something like this. And you notice that once you break and then you join with your friends on the left and the right, you have 4 bonds for carbon and all the bonds are fulfilled nicely. And this is the reason why you cannot have anything on the side. If you draw anything on the side, then you cannot hold hands already. Okay, so the whole purpose of not joining anything on the side is that when you break your CC double bond, the extra bonds will go to the left and right.
Granted a valuable telecoms license by the government. In 2015, it was the Isabel dos Santos-led urban redevelopment project being greenlit by presidential decree that the leaked documents later.
All right, okay. This is your drawing of your CCE double bond. And then you break it, you form it in the chain. Okay, next, let's talk about repeat unit. Okay, repeat unit basically is you can draw just one unit to represent everything. So you can see that this is actually like a repeat unit. This is also a repeat unit. This is also a repeat unit. So to make things very easy, repeat unit is just like this. Or it's just the monomer. You break the CC double bond. Oh shit. Alamak, let me draw this again. Let's do a quick refresher. So always draw it like this. So 3 units. Okay, after that, we'll break the CC bond. And then connect on the side. So break 1, break 2, break 3, and then we join them up. So this is the reason why we cannot draw anything on the side. Otherwise, it cannot be drawn this way. And then we also mentioned that this is repeat unit. This is also all repeat unit. So the repeat unit is just one part of your polymer drawing, or simply it is the monomer Okay, you will go on to break the CC double bond and then put a bond on the left and right will do. Okay, so that means it's basically this case, which is your monomer. You break the CC double bond and it turns into this. This is also how we can derive our repeat. Okay, any questions regarding to this? Okay, and the last one for the polymer. If the question did say 3 units, but ask us for the polymer, then what should we do? Okay, so in this case, all you need to do is to use the repeat unit and put an N here and say N represents a large number of units, which means in this case, we just need to draw a bracket because times N times. We do not know how many N are there, how many sets are there. All we know that this is a large number of units. Okay, if no question, let's try out this. Polypropylene, the formula is C3H6. And the basic structure of this, if you recall, we draw it like this. And complete everything. Remember this format you don't like. We need to draw it to the correct format. Give you all a few minutes to try this out. Make sure the rules that you follow should follow exactly what we do over here. Okay, remember the monomer has to be drawn like this. Otherwise, everything will be wrong. Okay, turn this into, remember the monomer must be like this.
Wait,
Okay.
sir, can you screw up for a while?
Yeah. Okay, I'll leave this here. So I'll give you a few minutes to draw the structure of polypropylene. You'll see how it goes. We'll go through in a few minutes. So for this case, you notice that there's 3 carbon. Then how do we arrange it? Remember, the idea is always the CC double bond. This is all it matters. So I have my CC double bond, and everything else has to be on top and below of it. So when you look at the structure, the two on top of the 2 carbon is the 2 hydrogen. Very straightforward. We didn't change anything. The one on the left, we put it on the bottom left, and everything on the right. Everything on the right of the CC double bond, which is essentially the entire CH3 molecule, will be here. This is the correct format for this. Of course, we should have drawn it this way. No space, so I just put a CH3 over there. All right, so this should be the correct way to draw the monomer for propene. Let's draw the one with the 3 units first. So same thing, I'll draw my 3 structure. Remember, this CH3 is because I'm lazy. Otherwise, I should have drawn the whole thing out. If I write like this. So same thing, we'll draw 3 of them. Okay, next, we'll break the CC double bond. And then we join them up together. This is polymer showing 3 units. Okay. Repeat unit, you can choose this, you can choose this, you can choose this. So just draw. Oops, no more double bond ring. This is our repeat unit. And for the polymer, if there's no mention about drawing how many units, we'll just draw the repeat unit. With the bracket with an N, and N represents a large number of molecules. This is the answer for polypropylene. Okay, anyone, any questions for this? All right, any questions for this? If not, we go to the last two, which is condensation polymer, and we are done.
Wait, Mr. Jason,
Mhm.
for the structural formula of the repeated unit, is it like there's a H at the right side?
Aha.
Wait, why?
Accident.
Oh,
Yeah, correct. Okay, no questions. Condensation. Right, so for this case, a little bit different. Because previously we were doing addition, CC double bond broken, right? Condensation, no. Just now we mentioned that the reaction involved the dropping of a small molecule. So what's actually happening here? Okay, you can see the name here, polyester. So we are likely forming an ester. Okay. Over here, you see the monomer is called a diol and a diacid. What does that? What is a diol and a diacid? A diol, as the name suggests, 2 alcohol. Okay. Before we do this, I mean, separate this page into half. Let me just separate this into half. Whatever we are doing now. So this is how a diol looks like. Okay, because these are huge molecules, right? And the components of the alcohol and the acid used, sometimes we do not know. So we will represent them by a box. This box can be C6, H or anything. We do not know what's inside. Just a box will do. Okay. So this box here has an OH, has an OH. This is our diol. Okay, the box represents a formula. Okay, whatever the formula is, it just represents a formula. Now, the acid is the same thing. C double bond OOH. Diacid means that you have two acid group, and there's also a box here. Okay, so we have a white box here and a black box for the acid. Okay, just to distinguish them. So the black box is for the acid, the white box is for the diol. So diacid means that you have two acid group also. This is our diacid. So just remember, in real terms, the boxes has a formula, got C something inside. So as we do esters just now, formation of esters, we say that the acid will drop the OH. The alcohol group will drop the hydrogen. Then we join them up together. So let's try to drop two acid. Let me squeeze in here. I will color code them, then easier to see. So my acid, I will draw it in blue. So this is the black box. Okay, so how does when they react together, right? As we mentioned, the alcohol group with the one OH, it will drop the hydrogen. The one with the acid group, they will drop the OH. Same thing, all this in green that we underline, they will be dropped off to form a molecule of water. So at the end of the day, you get this structure. So where they drop, they will bond together. So we connect to the acid. The acid here will connect to the next alcohol. And the next alcohol will connect to the next acid. Again, there are thousands and hundreds and thousands of these monomers. So you keep extending to the next alcohol and so on. But again, we cannot drop. So that's all we will draw. So you can see that the structure itself also duplicates. So this is actually one repeat unit. This is another repeat unit. So for answer for repeat units will be this one. Okay, this is the repeat unit. Any question? Basically, it's just dropping uh, hydrogen from the alcohol, dropping OH from the acid, and then just join them up. Maybe the highlighted parts here. Maybe all the highlighted parts. Yeah, actually the ester linkage. Whatever that we highlighted over there is actually the ester linkage. So the structural formula for we'll just take the repeat units. And we put an N, where N represents the large number of molecules. Okay, comfortable. This is how it looks like. So this thing here, they need two monomers to work. And one monomer has two alcohol group. One monomer has two acid group. They drop and join, drop and join. Okay, any questions from anyone? Right, if there's no question, let's do the same thing for the last structure. So this case, we are doing polyester because there's a lot of ester linkages. So we call it polyester. Next page, same thing, help me divide this page into half. Okay, this is called a polyamide. It basically contains a diamine and a diacid. Instead of a diol, now it's a diamine. So let me show you how a diamine looks like. Okay, a diamine is a nitrogen. This is your diamine. And your acid is the same thing. Okay, so if you go by the same logic, can you all help me draw? How do you think the polyamide will look like? Drop the same thing. Drop OH, drop hydrogen. Join them together. The logic is exactly the same. Just that now, instead of a diol, it's a diamine. That's it. But the logic is the same. Okay, please try all this. And then same thing for the equation. You can draw two amine and two acid, and then drop accordingly. And then join them all together. You see what you get. The logic is the same. Acid will always drop the OH and things like that. And because we didn't really mention what exactly is the amide, after you drop already, right? Just like how we identify the ester linkage just now, identify what is the amide linkage. Okay, give you a few minutes to sort this out. Okay, so if you have gotten the drift of it, you will see that because they will drop a small molecule when they react. So very logically here, you will drop water. The amine side, you should drop the hydrogen. The acid side, you will drop the H. So these two, they form water. These two, they form water. Same thing, the H and the OH. These two will form water. The one on the sides, do they form water? They do. Just we cannot show the whole chain because there's like thousands and tens of thousands of it. So we can only show the middle portion. So after the reaction, your correct structure should look like this. Okay, whether you draw the H on top or below the nitrogen, not important. And then the acid in blue. Okay, then you will see that the part where they join up is the linkage. So technically, this, this. Okay, it is your amide linkage. Amide linkage is essentially C double bond O and H. This is amide linkage. If you have gotten it correctly in the same idea. Okay, and then your repeat units. You can start here from the brown to the end bottom. And repeat unit. And then you have another repeat unit. So our repeat units, we can draw it with either one of the yellow underlined ones. So we have this C double bond O, black box, and C double bond O. This is your repeat unit. So for polymer, we'll simply put bracket N. This same thing represents large number of molecules. That's how your polyamide looks like. And while they react, remember the gist of it is that they will always drop a small molecule, and in this case, the small molecule is water. All right, any question from anyone? Okay, so you can see from both the polyamide and the polyester, they require two different monomers. One of them, like in this case for the polyester, one of them containing 2OH, the other one containing 2 acid. Polyamide one with two NH2 groups or your amine group, and then the other one with your two acid. So it appears that when you want to do polyamide or polyester, you need one, or rather you need two different monomers with two different functional groups in order for it to work. Why do I ask you to draw? It's my question. We do it with one single monomer. And the answer confirmed is yes, otherwise I won't ask you to draw it. Okay, so how do we draw this with a single monomer? Okay, because an ester require an alcohol group and an acid group to react. So how will our monomer, our single monomer works? That means our monomer will look like this. One side having the OH, the other side having the acid. In this case, then we will just have a single monomer that will do both of the monomer job on the left-hand side. How would the equation look like then? Okay, let me also draw the same thing. I will draw 4 again. So if you only want to work with one monomer, then that single monomer must have the two different groups there, the OH group and the acid group. So I don't draw two more, yeah, because no point, they are the same. So what happens is the same thing. The alcohol side will drop the H. This one will drop the OH, drop the H, drop the OH. Form water, you see, exactly the same. So at the end of the day, your structure will look like this. The rest all drop off it. So you can see this is also like one repeat unit on its own. This itself, you can draw two more, then you'll still look like the same thing. So this is actually our repeat unit also. Okay, so the repeat unit just simply this. Finally, for the polymer, we'll draw the repeat unit. And all right, any question? It's exactly the same thing, just that instead of using two monomers with two groups, I just redraw them into one monomer with two groups, one on the left, one on the right. Then he will react with himself. Okay, any questions? Okay, no question, we do the same thing, the last part of the polyamide. So as the same strategy goes, right, your monomer should be the one with one amine on the side, one acid group on the side. In fact, not important, for bio only, right? This thing is actually your amino acid. Your amino one side, acid on the other side. So by the same logic, if we were to draw two of the structures, okay, they will drop hydrogen for the amine side, OH for the acid. So drop the same thing, and eventually you will get this as your repeat unit. Again, because we only draw two only, right? So this one becomes the repeat unit naturally. So this thing here is also our repeat unit. And for the polymer, it's something like this. All right, this is still a polyamide. Okay, bear in mind, you should really recognize here it's our polyamide linkage. So it's still considered a polyamide. You can see that this is also our ester linkage. COO. Exactly the same as the previous case. All right, any questions from anybody? One last thing before we lock off. I'll give you a commercial name for these substances, because sometimes they ask us for nylon. Polyamides are nylon. So when they ask you for structure of nylon, it's actually structure of polyamide. Nylon you might have heard before, fabric and everything. Polyester also has a common name. It's called terylene. What is terylene? You can see it as fishing lines, that kind of material. It's also fabric, plasticky stuff. So terylene. Oh, so why do I bring this up? Questions also ask you draw the structure of this terylene. So to give you the monomer, and then ask you to draw it. And can also ask you for structure of the nylon that's produced. Okay, this is the gist of polymers. So before you all run off, right? Can you all help me look from here onwards? Addition polymers, addition of 18, addition of 14, then no polyester and polyamide. And if you are very comfortable for you tonight, if you are not comfortable with any of the points, please sort it out before you run off. Otherwise, you lock off after a few hours, everything will become blur water again. Okay, so if nothing else, can I give you a few minutes to digest through everything? If it's okay, then that's all for you tonight. You can run off already. Now make sure the last 4 pages are okay before you run off.
Wait, I have a question.
Yes.
For like for the single monomer, right?
Yeah.
Can you explain how you got it again? Like I know you split in half, but then like can you explain your thought process again?
The thought process is that in order to form the structure for polyamide or polyester, right, you need to have continuous alcohol and acid, or continuous amine and acid. And in order to cater to that, we started off with 2 monomers. One that contains 2 amine group, like in this case over here, 2 amine group and 2 acid group. So they can continuously connect and hold hands on the left and right side after dropping the H and the OH. But if you were to do the same thing, but you will only want to work with 1 monomer, then that single monomer must contain the 2 functional groups that will react with them. So on the left side, we see our diamine. The functional group is the amine group. The other one is your acid group. So we will give this new monomer 1 amine group and 1 ester group so that he can hold hands with himself. So the logic is the single monomer must contain the 2 functional groups on its left and right side that will react with each other. So in this case, it's our amine on one side, acid on the other side. For the single polyester monomer, we have alcohol on one side, acid on the other side, so that they can react together. So the idea is put 2 different functional groups on that single monomer and let them react. Otherwise, we will have to use 2 different monomers with the 2 functional groups on each side so that they can connect in a long straight line. Yeah, but if you do not want that, make sure each side has one of the monomer that can react with that with itself. That's the thinking process. Got it?
Yeah, thank you so much.
Yeah. The rest of you, if you all are already done, no issue, then you want to run off, you can run off for tonight. Next week, we'll be doing organic chem practice. So next week, you can bring out the organic chem questions. You should be doing that next week.